Um, Still looking at solving equations and using, in this case, with a story problem that we've got to focus on how the dimensions of these things work together. Okay. So it says the cedar chest has a length that's 3 feet longer than its width and a height that is 1 foot longer than its width. The volume of chest is 30 cubic feet. What is the width? So first of all, the fact is we're dealing with volume and we're dealing with a cedar chest. So what does a cedar chest look like? How many of you have ever seen one? Okay, Spencer, what does it look like? Okay, big treasure chest. Okay, so it is the shape of a box, though, right? So we have to deal with length, width, and height. So here we have volume for a box is equal to length times width times height. Okay? And they give us some specifics. They tell us that the length is 3 feet longer than its width. So I can say that L is equal to W plus 3. And it says the height is 1 foot longer than the width. So H is W plus 1. So if we call this W, then this is W plus 3, and this is W plus 1. So then all I need to do to solve this is write it as an equation. We have the width times the length times the height. And that is equal to 30. So you could legitimately, in this case, you could figure it out in your head probably without doing a bunch of work. Because if you think about it, we're multiplying 3 numbers together, and they have to equal 30. Okay. So I could do 1, 1, and 30, couldn't I? Except that doesn't follow this. Okay. What's another combination of numbers that would give me 30? 3 and 10. So I could say 1 times 3 times 10. That would give me 30. But that doesn't work either, does it? Okay. If the width is 1, that's not plus 1, that's not plus 3. Okay. So we could just guess and check until we end up with those numbers to do it. Okay. And we could also do the multiplication. Okay. Multiply this all out. Okay. And actually, this isn't overly difficult to do the multiplication here. And let's do that real quick. Take a look at that. So what do I get when I multiply these two together, W plus 3 and W plus 1? Okay? There's some simple foiling there that you've all done lots of. So that would be W squared plus 4W plus 3. So then we can finish the multiplication. W cubed, 4W squared, plus 3W. Now, if I want to be able to factor, what I really want to do is, it would be really nice if I could factor this and find the zeros. Okay. No. So I want to get it equal to 0, so I'm going to subtract 30. Okay. Because I like to work with 0 better than anything else. So if I subtract 30, I get this equation. And it'd be really nice if I could factor that. Can I factor that? It's a cubic, 4 terms. You got to think about grouping. Okay. If I factor these, I get W squared and W plus 4. Okay. Does 4 go into 30? Goes into 28 and 32, right? It doesn't go into 30. So I can't factor this by grouping, so we're going to have to use our calculator to find the answers. So we're going to put this in your y equals of your calculator. All right, and this is what we're going to be doing here. Here's a little skill that you're going to have a lot of practice with. All right, we're going to be doing this quite a bit. So first thing, if you just grabbed one of my calculators back there, the first thing you need to do is make sure you go to the y equals, clear it of course, but make sure there's no plots on. So if plot 1 is highlighted, make sure you go up and hit plot 1 so it's no longer highlighted, because it may be because they were just doing that last hour. So x cubed plus 4x squared plus 3x minus 30. And we want to know, when does that equal 0? So you could put 0 here in y2, but you don't have to. And I just noticed Mr. Greca went and got a pencil, which is fine, just that there was about 10 of them in there a couple weeks ago, or last week, and there's about 3 inches in there, 4 inches in there? Okay, 3 pretty short ones. So if you borrowed one, you might want to think about putting it back, so, at some point in time. All right, so we look at the graph. Press zoom 6 so I get a good window. Here's the different. Okay. Oh, you came up with one? All right. Okay. So we can see that in this case, it only crosses the x-axis once, right? And where is that at? At 2. Okay. So their question was, what is the width of the chest? So the width is 2 feet. Now, most of the time when you have problems like this, okay, you're not going to be able to get it down to something that's nicely factorable, okay? So in that case, we could have actually went to here at this part and found our answer there. So we could have went to our, let me show you this again. All right. So if instead I use the factored form, so I put x times x plus 3 times x plus 1. And now I just want to know when it equals 30, right? Okay. So if I go to my table then, right, I can see that it equals 30 when x is 2. So I could have found the answer back there at that point in time. So the point is, okay, that if you can write it in factored form, use your calculator and find it, then that's fine. You don't necessarily need to do the multiply it all out to get there. If you do, certainly okay. So let's see what happens if we put 2 in. I get 2, 5, and 3, right? Okay. See, 2 times 3 is 6, and 6 times 5 is 30. Okay, so that worked. Okay. So the width would have been 2, the length would have been 5, and the height would have been 3. But in this case, they just want to know what the width was. Okay. At identifying all the real roots of a polynomial equation. All right, and yes, we're going to use 11 through 14. We're not going to use my examples up here. Okay, we'll go ahead and use those numbers. So here's the first thing we're going to do. Okay, is that we're going to look to see if we can factor it. Okay, if it's something I can factor, great. It'll be shouldn't be too bad doing it. Okay, if I can't factor it, then I'm going to graph it to find the integer zeros. What are integers? They are numbers. Not greater than 1 necessarily. Okay. Okay. They are positive and negative whole numbers. 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, and so on. Okay? So we're looking for integer zeros. Okay? Now, once we've found our integer zeros, then we're going to use synthetic division to reduce a function to a quadratic, so that then I can either use the quadratic formula or factoring or completing a square, any of those then, to find the answer. All right, so it says if you cannot reduce it to a quadratic, then you can just use your calculator to find the zeros. And I'm going to specifically show you how to do that also for the ones that are not. Okay? All right, so the first one we're going to look at is number 11. So let me bring that one back up here. So here we have a cubic function, has 4 terms, so I'll look to see if I can factor it. Can you factor this? Okay, so I'm looking at, since it has 4 terms, can I factor it by grouping? All right, so let's see. Because if I can, I'm good to go. So these first two have x squared in common. So I have x plus 6. The last two have what in common? 5. Okay, negative 5. Oh, look at that. X plus 6. Okay, so great. So this one can be factored. All right, that makes it a whole lot easier for me if I can factor it. So now I can write it as x plus 6 times x squared minus 5. So then we use the zero product property then. Because can you factor x squared minus 5? No. Okay, you can't. I can. All right. Because I know these, it has to be square root. Okay? But that's okay. We don't need to factor it then. So I'm going to set these both then equal to 0. And solve them. So we get negative 6 for the first one. Okay. All right, but then there's this other one. What do I do to solve that one?
Square root of 5 is the answer.
Well, first thing I have to do what with the 5? Okay, add it to both sides. I got to move it to the other side. Okay. And then how do I get rid of the squared sign? Okay, we take the square root. Now here's the big thing is don't forget, when you take the square root, that means you get plus or minus square root of 5. Okay? Not just the square root of 5, but plus or minus square root of 5. So then that would be my answer, that x equals negative 6 or x equals plus or minus 5. Okay? So hey, we have a third degree polynomial, so there are 3 zeros potentially, and I did come up with 3 of them. Okay? And if we look at our calculator, okay, what did you say?
Where's the third zero?
Negative 6,
Oh.
positive square root of 5, and negative square root of 5. Okay? So if I look at it graphically, all right, so we've got x cubed plus 6x squared minus 5x minus 30. If I graph it, we can see there's a 0 here at negative 6. Okay. 1, 2, 3, 4, 5, 6. Okay, negative 6. And then there's 2 other ones here. Okay. Now, I can check it, right? So I'm going to press trace. Right? If I typed in -6, yep, there's that 0. And I can check the square root of 5 then by putting in square root of 5 now. And hit enter. And that's equal to 0 also. And negative square root of 5. Okay, that one's 0. Okay. So it worked. What I did was correct. Now, what if you can't figure this out but you just want to be able to find the zeros? Okay? All right, Mr. Coffey, I'm willing to take a 1-point deduction because I can't figure out what that radical is. So I'm just going to find the zeros with my calculator. Does anybody know how to do that? Okay? All right, nobody does. Good. So I'm going to show you. All right, so this is how you use your calculator to find the zeros. Okay? All right? So we're going to graph it first of all. Okay, how many people have graphed this on your calculator? If you haven't, do it right now. Okay. Put that function in your y equals. The original equation, original function, put that in your y equals. I'm going to show you how to find those zeros that are not nice numbers. Or they're not integers anyways. How many of you know how to use your calculator to find intersection points? All right, great. Okay. Okay. All right, so go to second and trace to calculate. How many of you seen this, remember this screen now? That looks familiar. Okay. All right. So we've used that to find intersection points before. So I could put 0 in my y2 and find out where that graph hits 0 that way. Or I can use what's called the zero finder here on number 2. Okay. So we're going to select number 2. Now it asks for the left boundary, okay, which means that I want to have my x value to the left of where the graph crosses the x-axis. Okay, all right. And right now I can see that it does, but I want to be perfectly sure. Okay, so I can see that this 0 is between -2 and -3, right? Can you guys all see that? Okay, so my left boundary can be anything to the left of where this point is. So it could be -3, couldn't it? Or -4 or -5. Okay? So what you can do is your calculator will allow you to type in the number you want for the boundary. So you could type in right now -3 and press enter. And you'll see that it gives me the number for -3 is 12. And you see it puts this little triangle on your screen. Okay? Now we want to pick a number to the right of where that 0 is. Okay, a right boundary. Well, the right boundary then, I just needed to be to the right of that point, so I could choose -2, or I could choose -1, or 0, whatever you wanted to choose, just as long as it's before we get to another intersection. So I could put in -1 now. Okay, and you can see it puts another triangle there, but this one points to the right, or to the left, and it tells me at -1, y equals -20. So my answer for where this crosses the x-axis is going to be between those two triangles. So now for guess, I can just hit enter there when it says guess. And there it takes us to -2.236, which is the square root of 5. Okay. All right, so let's do it for this one over here also. Okay. Find this one over here. So we hit second trace. Second trace, number 2 for 0. Okay. And now we're looking at this one here. So my left boundary then is got to be to the left of where this is crossing the x-axis. So I could use +2, +1, 0. I could use any of those numbers. Okay. So I'm going to go ahead and use 0 this time. Okay, so it tells me at 0, I get negative 30. Okay, but my arrow here, it points to the right. It's to the left of where that spot is. Now I need to pick a number over to the right of that for right boundary. So I could choose 3, 4, 5, 6, 7, whatever you want. All right, I'll choose 3 this time. Okay. And it says at 3, it's positive 36. But where's that point at? That point is between these two arrows now, okay, or triangles, whatever you want to call them. And if I hit enter for my guess, then it'll take me to that spot, positive 2.236, or the positive square root of 5. Okay? So that's how, if it doesn't give you integer zeros, okay, then that's one way you can use to find the zeros, okay, is by using that zero finder. All right, so let's do another one of these. Let's do number 12. We'll come back to that statement there. Okay, now, looking at number 12 here, is this something that I can factor? Okay, let's see. If I took out 3x squared, I'd be left with x minus 6. Well, does 9 go into 132 6 times?
Yes, it does. No, it doesn't.
It goes into a lot more than 6, doesn't it? Okay, because 9 goes into 54 6 times. So if I factored that, would I get x minus 6 here?
No.
No, I wouldn't. So this one cannot be factored by grouping. So what I'm going to do then is now I'm going to just graph it. So put this in your y equals. I think I goofed. Okay. All right. So when we graph it, we can see that it crosses the x-axis 3 times. Awesome. The first one here, there's one between -2 and -3. Then I go down here, 1, 2, 3. Looks like there might be one at 4, and then there's one between 4 and 5. So I got 2 options for checking to see if there's one at 4. One, I could go to my table and look. That's probably the fastest way. I'll go to my table, and yes, I do have one at 4. Okay. And the other one is a decimal number. Okay. All right. So what we're going to do is we're going to use the 0 that we can find, that x equals 4. Right? And then there are 2 other zeros there, right? Well, we can use synthetic division now to take this cubic function and reduce it down to a quadratic function. Okay? Once I get it to a quadratic, I can use a lot of different things to find the zeros, find the other 2 zeros, because my object is to find out exactly what they are, not just graph it and find some decimal numbers. Okay, I want to find out exactly what they are. So we're going to do synthetic division so that I can get this cubic to a quadratic to where I can find the exact values. No, it's 4. 4 is the 0 that we found, so we use that number. So we bring down to 3. 4 times 3 is 12, so we get negative 6. Multiply by negative 6 and we get negative 24. So negative 33 when I add them. And 4 times negative 33 better be 132 negative. So what I've just done is I've taken this cubic function and I've now reduced it to a quadratic. So this is 3x squared minus 6x minus 33, right? Okay. Basically, I factored it. Okay. Now, one nice thing about this is these are all multiples of 3, aren't they? Okay. So instead of having, because what I want to do is solve this equation now. Now I want to solve that equation to find the other two zeros. Well, first thing I can do is I can divide by 3, can't I? Okay, we could have done that up here, but here I can see it for sure. I could divide each of those by 3. So we get, if I divide the whole thing by 3, we get x squared minus 2x minus 11. Okay. Can we factor that? Factors 11 are 11 and 1, and they don't add up to 2. Okay. All right, so then we've got to use the quadratic formula. So the nice thing about it is, though, is that when we use the quadratic formula, here you go. So once we find, we can get it down, once we get it down to a quadratic, then we can use the quadratic formula if we can't factor it. Okay? And so here's the quadratic formula for those of you who don't remember it. Okay? And that's because it's in the form A, our equation's in the form ax squared plus bx plus c. So where these are the values of A, B, and C. Now when I write it a little bit differently here. I like to pull it apart. I don't do it exactly like that, but I'll show you as I do it. Okay. Okay. You guys remember how to use quadratic formula because it hasn't been that long for most of you, right? Okay. Right.
Couldn't we do the second trace zero thing though if we wanted to find them too?
You could do that if you want to, but you need to find the exact values. That gives you decimal values. That does not give you the exact value. Okay, unless you're going to write out 400 decimal places. All right. Okay. So the one thing about it is that when you do the synthetic division, here's A, here's B, here's C. It gives it to you. Okay. Except we're going to use 1, -2, and -11 because they're easy to work with. All right. So we got the opposite of B, so the opposite of -2 over 2 times A. Okay. Like I said, I pull it apart. I don't make it as one single fraction. I do it 2 fractions. It's easier to simplify there. Okay. Plus or minus square root of B squared. Make sure if it's negative that you put it in parentheses. Okay, because we need to get a positive number. Minus 4 times A times C. And that's divided by 2 times A. Okay. All right, and then we're going to simplify it. So we get 2 negatives make a positive, right? So 2 over 2 plus or minus. And here we get 4 plus 44. So square root of 48 over 2. Okay, that's the way I do it. I pull them apart. Okay. How many of you remember how to simplify square root of 48? That would have been something you did in chapter 5 also. Okay, here's our squares, right? Hey, look at that. We got them right here. What's the biggest one of these that goes into 48? 36 go into 48? No. Okay, 25 doesn't. 16, Cody says 16 goes into 48. Is that true? Okay, all right. So the square root of 48, I can write as the square root of 16 times 3. And what's the square root of 16? 4. So this is 4 times the square root of 3. So here we've got 2 over 2 plus or minus 4 square roots of 3 over 2. All right. And this can be simplified. So 1 plus or minus 2 square roots of 3. So there's 2 answers. 1 plus 2 square roots of 3, 1 minus 2 square roots of 3, and then my third 0 is x equals 4. And here, once again, I could check these. Since I've graphed it, I can hit trace, type in 1 plus 2 square roots of 3, okay, just like it is there, and hit enter, and it equals 0. So here's the thing. Cody says, well, you know what, Mr. Coffee, why can't I just do that? Okay. Right. You can, all right, if you want. If you just want to find the 0, you can. 4.464. Sure. Okay. It's just that won't give you full credit on a quiz or a test. That would reduce your score by a point. So if you're okay with that, great. Okay. All right.
The only time we get full credit for this.
Right. If they give you, if you can't get it to a quadratic, okay, so let's say that, let me see if I find one here. Number 16, you're going to do that. That one can be factored. But like number 16 here, if I graph this and I only found 1 0, then I could not get, by doing synthetic division, I could only get it down to 4th degree. So then my only option would be to then graph it and find the zeros. Okay. Or, I know it's over here too. I think this one, number 24 might be like that. I don't know if it is or not, but okay, to where, oh no, that's a factorable one too. 33 is, okay, here's x to the 5th. You're probably not going to find enough real zeros to get this down to a quadratic, so then just by finding them, you would work with your calculator. Okay. Yeah, sometimes that happens. Okay. All right, so we need to do one more. And then get you working. Okay, so let's do, where are we at here? Number 14 then. Okay, this will be our last one, and I'll give you your assignment. So remember, first thing I'm looking for is, can I factor it? Is this something that can be factored? Let's see. It's to the 4th power here, but this was to the 2nd power. The middle term is. So we said if the first term or the degree is double that middle one, then I can look to factoring it. Okay. So what are the factors of 20 that add up to 9? Okay. 4 and 5. So I can rewrite this then as x squared minus 4 times x squared minus 5 equals 0. Now then, I can set those two parts equal to 0 and solve them. So we get x squared equals 4 when I add 4, and x squared equals 5 when I add 5. And then I do what? Okay, take the square root of both sides. And just remember that when you do square root, you get plus or minus. So x equals plus or minus 2 for this one, and plus or minus the square root of 5 for that one.
So this crosses x 4
Okay.
times.
So this crosses the x-axis 4 times. That's correct. Okay, and if you graphed it, you would find it plus or minus 2 and plus or minus 2.23, whatever that number was. Okay? All right? And here's the thing. Whenever you get x squared minus something equals 0, you always know it's going to be plus or minus that square root of that number. Okay? Questions?